So the final question asks us to take a look at the MT-CARS data set and basically do a t-test and a z-test assuming an equal variance, and it wants us to give us a p-value for comparing miles per gallon for 6 cylinders to 8 cylinders cars. So I've already defined M6. My 6-cylinder miles per gallon, my miles per gallon for 6-cylinder cars that I've sampled, and M8 for my miles per gallon for 8-cylinder cars that I've sampled. Now I want to do t.test M6 and M8, and I want to put var.equal is true. There you go. T.test. Make sure you type in the right word. Okay, so t statistic is 4.419, so our difference in means is 4.419 standard errors away from 0. The p-value is effectively 0. At least it's 0 to 3 decimal places, what we need for the question. And then notice that the only difference between the t statistic and the z statistic is whether we compare our statistic to the t distribution or the z distribution. So if I wanted my my z-test rather than my t-test, I could just take the same statistic value, 4.419. So 2 star p norm. And then I don't want to type lower.tail equals false, so why don't I put negative 4.419? Okay, and that gives me my normal probability. Let's go through calculating this test statistic manually, just so we understand what's going on. So let me define mean 6 as the mean for the 6-cylinder cars, mean 8 as the mean for the 8-cylinder cars. S6 is the standard deviation for the 6-cylinder cars, and S8 as the standard deviation for the 8-cylinder cars. N6 as the number of observations for the 6-cylinder cars, and N8 as the number of observations for the 8-cylinder cars. Okay? First we need the pooled variance estimate. So we want S sub pool, and that's going to be the square root. Let's get a square root in there. And then I need a second parentheses, and then a third parentheses. So then I want N6 minus 1 times S6 squared plus N8 minus 1 star S8 squared. And then let's double check my parentheses. So that's the numerator. And then I want that divided by N6 plus N8 minus 2. Okay. And there's I have an unexpected parentheses. Let's double check. Okay. Let's see. 2.27. Okay. So my t-test is going to be my mean for 6 minus my mean for 8 divided by S of p. Well, let me just put it in parentheses. S of p times square root 1 over n1 plus 1 over n2. Okay? Not n1 and n2. Sorry. n6 and n8. Okay, 4.42, just like we had before. Let's scroll up let me just scroll back to my t-test. There we go. And there it is, 4.419. So that also gives me my pooled variance estimate, 2.26. So let's see, I can fill in some of my answers here. So the first p-value was 0 to 3 decimal places. The second p-value was 0 to 3 decimal places. The common standard deviation was 2.2696676. I'm going to enter them all in just so I make sure I don't mess up the significant digits that it's requiring for. And would it reject? Well, the p-value is really, really small, and so it's clearly less than any normal standard, and I even give 5% there. I mentioned that. So, okay, 1 for yes. Okay. And then if we hit submit, oh, it doesn't like my zeros. It doesn't like my zeros. I wonder if I give it 3 decimal places, if that's the problem. No. So again, for whatever the reason, the JavaScript is not liking when you input exactly 0, however it's testing it. I'm sure probably what I need to do is have some machine tolerance for the answer there. But I'll fix that. And so the key thing for this problem for you to understand is just to make sure you can do these manipulations. These are, I in general, you probably won't need to manually create the t-statistic, but you should go through it once or twice, and more than anything, just to understand what the t-statistic is. On to the last problem, and it just is a very simple multiple comparisons question. It just says the Bonferroni correction controls the false discovery rate, the family-wise error rate, the rate of true rejections, and the number of true rejections. And it is the family-wise error rate. That's just a definition. If you look back at the lecture, that is what the Bonferroni correction is trying to go for. Trying to control the probability that we make at least one error. So it's a very strict criteria. In many cases, you may not want to control the error rate at such a strict criteria, and that's why people have developed other things like false discovery rates. But this is just the definition of the Bonferroni correction. Okay, so that's the end of the homework. This is a marathon homework. Again, sorry about the grading errors, but I'm hoping when you look through the answers that you got the problem correct. These problems are very similar to a lot of the quiz questions, so I'm hoping they'll help you attack the quiz questions. And again, remember, I wrote the problem, so it's a little bit easier for me to go through them than it should be for you going through this the first time if you haven't seen these kinds of problems before. I'll also admit that the wording is a little tricky sometimes, but that's intentional. The idea is if we tell you that the mean is this and the variance is this and just execute a t-statistic, then that's not really kind of stretching your statistics muscles for sort of diving into a problem, pulling out the relevant information. And I'm hoping that these kinds of exercises will sort of train you so that when you're in sort of a real life scenario, your sort of mental statistic muscles will be very strong for sort of extracting the relevant information from the problem as it's being sort of dynamically discussed and getting at the right, or at least a good solution. Okay, so that's the me going through all 4 homeworks now. I'm sorry the video quality wasn't the best, but I'm hoping that me talking through these things was useful for you.